Welcome back to section 21. In this video we'll be going over example 1, which looks at how to find the natural response once we've found the differential equation for our circuit. So I've rewritten that over here. So find the natural response given dv dt, so second derivative of v plus 6 first derivative of v plus 8, and that should be a v there. It's not a constant because we don't have a forcing function here, equal to 0. So we know that we're going to basically have a form where we need to find s is equal to the quadratic equation here. So if you want to, and we can do that, we're going to say that d dt equals s. So normally I won't do this, I'll just pull the numbers. So we're going to say d dt equals s, and so when I do that, we'll get s squared. I'm going to drop the v's, plus 6s plus 8 equal to 0. And even if you have a forcing function, you drop this to 0, just because we're finding the natural response, which is not forced. So s is negative 6 plus or minus square root 6 squared minus 4 times 8 all over 2. Remember, our coefficient in front of here should be a 1. So just standard quadratic equation. So you do that, you get minus 6 plus or minus, we get 36 minus 32 inside negative 6 plus or minus square root. So that is root 4 over 2. 2 over 2, and that becomes negative 3 plus or minus 1, which means that our roots are s1 is, we'll go negative 3 plus 1, so negative 2, and s2 is negative 4. It doesn't matter which one's s1, which one's s2, just so you know. So if you flip these, it wouldn't matter. So these are both real. These are both distinct, which means that we are underdamped. So we're going to be using the one that looks like what you've seen before, A1 e to the s1t, A2 e to the s2t. So it looks just like what you've seen before, except there's 2 roots instead of 1 root. So our v natural will be A1 e to the negative 2t plus a2e to the negative 4t. And all that would happen if you flipped these is this would be negative 4 and this would be negative 2. You'd find the right constant that goes with that. You'd find the right constant that goes with that. I should also mention, I did in the last video, that these are stable because they are both negative. If your real part of your roots, so this isn't part of this. Basically, at this point we've solved this, by the way. We're done. But if for some reason we got that this was s1 equal negative 2 plus or minus a j4, sorry, that'd be s1 and 2, that would still be stable because the real part is negative. I didn't mention that last time. I just wanted to make a quick note of that. If you had a positive 2, though, that would be unstable, and that circuit would kind of shake itself apart if you think of like a suspension system or something. All right, hopefully that helps. If you have any questions, feel free to reach out.